Good morning all of you. I am Shraddha Kushwaha of class 11th A and today I'll tell you how to measure the radius of curvature of any spherical surface. This is a spherometer. It is used for measuring the radius of curvature of spherical surfaces. It works on the principle of micrometer screw. The parts of spherometer consist of a metallic tripod framework supported on three fixed legs of equal length. A screw passes through the center of the tripod frame is parallel to the three legs. A large circular disc graduated with 100 equal parts is attached to the top of the screw. A small vertical scale known as the pitch scale with the scale reading divided into millimeters is fixed at one end of the tripod. So today we are going to measure the radius of curvature of a spherical surface. So the radius of curvature of that spherical surface is given by this formula r equals to L square upon 6h plus h upon 2, where r is the radius of curvature, h is the difference between the reading of the curved and plane surface. I will be telling you how to calculate this h. L is the mean distance between the three legs of the spherometer. The formula for h is n into pitch plus x into least count. Now we will find the least count of the spherometer. First, measure the pitch of the screw. For this, find the value of one division on the pitch scale. Then bring the zero of the circular disc opposite to the pitch scale and rotate the screw by n complete rotation. So, as you can see, the zero of the circular disc is aligned with the zero of pitch scale. So now I am going to rotate this circular disc 3 times. One, 2, 3. So as you can see, the distance moved is 3 mm. 1, 2 and 3. This is the value of our D. Now we will note this D moved by the screw on the pitch scale, and the pitch of the screw is given by the formula pitch equals to D upon N. So here we had our D as 3 and N as 3. So the pitch of this spherometer is 1 mm. Now to find the least count, we will count the division on the circular disc. So here, as you can see, there are 100 small divisions on this circular scale. So we will divide the pitch of the spherometer by the number of division on this circular scale, which comes out to be 0.001 millimeter. So as I said, the number of rotations is equal to 3 and the distance moved on the main scale is 3 mm. So the formula for pitch is D upon N, which comes out to be 1 mm, and when converted into centimeters, it comes out to be 0.1 centimeter. So to find least count, we will use the formula pitch upon number of divisions on the circular scale, and the division on the circular scale was 100. So by putting these values in this formula, we get 1 upon 100 mm, which is 0.01 mm, or we can say 0.001 centimeter. Now we will find the mean distances between the legs. So to find this, first we will get the impression of the legs on a piece of paper. So to find this, first we will press the spherometer on the paper and mark its points, and now join them. Now measure these distances and find their mean. So this distance is 3.4 centimeter. Now measure this distance also. This is also 3.4 centimeter. And this one is also 3.4. So now we will find the mean distance between the legs and denote it by L, which comes out to be 3.4 centimeter plus 3.4 centimeter plus 3.4 centimeter whole divided by 3, which comes out to be 3.4 centimeter. Now we will measure the radius of curvature of a spherical surface with this spherometer. So now I am taking a convex mirror to measure its radius of curvature. So now place this spherical surface under the spherometer and raise the screw enough so that we can place the spherometer on the spherical surface. Now rotate the circular disc so that the screw just touches the surface of the spherical mirror. Now check that whether there is a gap between the tip of the screw and a spherical mirror by passing a piece of paper between them. So as you can notice, this piece of paper is able to pass between the gap. So we will rotate the circular disc further. Now check again. As you can notice, now this paper is not able to pass between the gap. So now we can take the reading of the circular disc. Now we will note the reading of the circular disc, which is in align with the 0 of the pitch scale. So we can see the number which is in align with the 0 is 50. So this is our reference point A. Now remove this spherical surface. Now rotate the circular disc enough so that the tip of the screw just touches the table surface. And then note the number of rotations this circular disc makes. So now it is at 50, and then rotate. Pass a paper strip to confirm that a gap exists or not. So as you can see, there is no gap between the screw and the table surface. So we will note the second reading, which is in align with the pitch scale. So it is 10.2. Okay, so the second reference point is 10.2. Now count the number of divisions between the reference point A and 2. So as you can see, the reference point B was 10.2 and the reference point A is 50. So when we will count this number of division between them, it comes out to be 38. Now we will calculate H. So for finding H, the formula is n into pitch plus x into least count. Here n is the number of rotation we had between our reference point A and B. So in this case, we had 0 number of rotations between our reference point A and B. So I have written down 0 for n. And pitch, we found the pitch as 0.1. Now x is the number of division between our reference point A and B, which came out to be 38. So we will write 38 here. And the least count was 0.001 centimeters. So the total reading came out to be 0.038. Now we will perform this same activity 2 more times to fill this table, and will take the mean of this total reading. So for now we have only one observation, so I am writing this as the final value, 0.038. Now we will calculate the radius of curvature. Its formula is L square upon 6h plus h upon 2. And as we have calculated it earlier, L was 3.4 and h was 0.038. So when we put these values in this formula, the answer comes out to be 50.72 centimeter. This is the radius of curvature of our curved surface. Thank you.